When we look up on a sunny day, the world is bathed in sunlight, illuminating everything around us. Yet, the concept of light becomes more mysterious when we think about space, the very place the sun exists. Outer space is dark, even though the sun shines brightly at its center. How is it possible that sunlight reaches Earth but leaves the vast stretches of space around it in darkness? To understand this, we need to grasp what light is and how it behaves. Light is a form of electromagnetic radiation traveling through space in the form of waves. It doesn't need air, water, or any other medium to travel, which is why it can move through the vacuum of space. When the sun emits light, it radiates in all directions, including toward Earth. However, light is invisible unless it interacts with something. This is where the key difference between space and Earth lies. Space is almost entirely empty, a vacuum with few particles, dust, or gas. Since light needs to hit objects to become visible, the vacuum of space remains dark. Even though the sun's light is streaming through, there's nothing for it to scatter or bounce off. Essentially, light passes through space undetected because there's nothing there to reflect it. On Earth, we experience light because our atmosphere is filled with particles, air molecules, dust, and water vapor. When sunlight hits these particles, it scatters, making the light visible to us. This scattering effect is why the sky appears blue, as shorter wavelengths of light, like blue, scatter more than longer wavelengths, like red. The ground, buildings, trees, and other objects on Earth also reflect sunlight, further contributing to the brightness we experience during the day. Even astronauts in space, relatively close to the sun, experience the darkness of space around them. When an astronaut looks toward the sun, they can see the blinding light. However, when they look away from the sun into the vastness of space, it's pitch black. This is because there is no atmosphere or objects in the void of space to reflect the sunlight back toward their eyes. Space appears dark because the light is not scattered or reflected by objects. This also explains why the stars seem to shine so brightly from space. With no atmosphere to scatter their light, stars appear as sharp, bright points in the darkness. The moon, like Earth, doesn't have a thick atmosphere. However, it appears bright from Earth because the surface of the moon reflects sunlight. When light strikes the moon's surface, the reflected light travels toward Earth, making the moon visible. This is the same principle that explains why planets and other celestial bodies are visible in the sky. The sun emits light in all directions, but it only becomes visible when it hits something. On Earth, our atmosphere and the objects around us scatter and reflect sunlight, making the world appear bright. In space, however, the absence of particles means light passes unnoticed, leaving the vast void in darkness, despite the sun shining nearby. Understanding this fascinating interaction between light, space, and Earth's atmosphere reveals the complex and beautiful nature of our universe. Light exists everywhere, but it only reveals itself when it has something to illuminate.